Welcome back. This is the second of 3 lessons in calorimetry. This one's on heat transfer and temperature change for 2 objects. When a hot and cold object are put in contact with each other, the amount of heat lost by the hot object is the same as the amount of heat gained by the cold object. So here I have a hot object, and here is the cold object. I have a hot iron and an ice cube. Now, here's how this lesson works. So basically, Q is the amount of heat. So Q lost, okay, is going to equal Q gained. So the amount of heat that this one loses when they touch each other is going to equal the amount of heat that this ice cube gains. Now, these two, when you put them in contact with each other, they will both reach, okay, when you put them in contact with each other, they will both reach eventually what we call thermal equilibrium. And all this means is that they reach the same temperature eventually, as long as you keep them in contact with each other eventually. Now, the formula that we need to know. Q1, so for object 1, and is going to be equal to the opposite of Q2 for object number 2. I wrote this wrong. That should say number 1. And is going to equal the opposite, or the negative of the heat for object 2. And all this means is Q amount of heat gained is equal to the opposite of the amount of heat lost. Now, all we need to do to solve these equations is set up a individual Q equals mc delta T for each of the 2 objects. Now, important thing to note about these problems is we're assuming that there is no phase change. Okay? We're also assuming that the final temperature is same for both objects because of thermal equilibrium.